The Rock Whisperer. Do you hear the earth talking to you?
The weather unit, winds, 5-6. So when we talk about winds, we can relate back to the pressure systems, high and low, that we talked about. And we said high pressure is going to be clockwise and outward, and low pressure is counterclockwise and inward. So winds refer to the general direction that the winds are moving. So that is also called prevailing winds. So the dominant direction that the wind blows. Again, we always talk about winds as where they are coming from. And in New York State, our general wind direction is going to be west, or maybe it's slightly southwesterly direction. And actually, if you go back to the website and look at the weather data for the entire year, the majority of the months come out prevailing winds are coming out of the west. This particular diagram I know you don't have in your notes. This shows you the global prevailing winds. This is in your Earth Science reference table, so you don't need to copy it down, but I just want to show you something. You can go back and look at it. Okay, similar to what you talked about, I know you've talked about trade winds in global studies and the westerlies, but we can see what's happening in these particular areas. Similar to the video we watched again, at the equator where the doldrums occurred, you have air that is rising straight up. That air is then going to descend at 30 degrees, which is where a vast majority of our deserts are. Same thing down on this end. Then around 60, that air is rising again, and it descends at the poles, north and south. And again, the poles, even though they're cold, they're considered deserts because of the lack of precipitation they have at times. So in the United States, weather systems usually travel about 500 to 600 miles a day. Now that varies slightly depending on whether it's warm air or cold air, moist air or dry air. Some of them have more friction and drag than others. But what you also need to know is that in the United States, from the west coast to the east coast, it's approximately 3,000 miles. So if we do some simple math here, we take 3,000 miles and we divide it by about 500 miles per day, we wind up with 6 days to travel from coast to coast. If we substitute in the 600 here, then it comes out to be about 5 days. So sometimes we can tell what the weather is going to be. If we look at what's happening on the west coast, we see a major storm coming onto the west coast. We know in approximately 5 to 6 days that storm system will be on the east coast. It may not impact us in New York State, but it could impact somewhere on the east coast of the United States. So when we talk about winds, we're talking about miles per hour, but there are a couple different scales that we need to be familiar with. And one of them is the Beaufort scale. So this is a wind scale. It tells us the wind speed. In this particular picture here, it also gives the terms that people at ocean may use for that. So there's a number, 0 to 12. There are wind speeds, calm, light breeze, gentle breeze, all the way up to when we sometimes hear the term gale, force winds. We're talking over 30 miles per hour. Some pictures showing you what some of the damage might be. Smoke coming out of your chimney, still going straight up. If there is light air slightly going in that direction. And it gives you a little bit of a description of what's going on. And then when we get down here to 73, and actually it's probably closer to 75, are hurricane forced winds. So this is another picture, and it shows the gentleman who created that scale, the anemometer that we talked about, calm winds, light breeze, and it shows you going through the different types of damage that would be occurring and what is going on with those particular things. So if you went back and you Google search this term or for diagrams, you can get a lot of variety of different things for that. When we talk about tornadoes, and we talk about the F scale for tornadoes, so the Fujicha scale, so we are talking anywhere from 40 to 73 as light damage, an F0. Then as we increase, we can see that F4, F5 is incredible damage. And that was the one video that we, in the BBC video again, gentleman that was in the drain pipe, hiding from the 300 plus mile per hour winds from that particular tornado. So we can see that there's a wide range of things that can occur. Majority of tornadoes that we get in our area, they do cause quite a bit of damage, but they're usually F0, F1, maybe an F2 in this area. Again, here is the scale. Here is the winds. They actually have one on this particular scale called an F6, which is 319 to sonic. This gives the percentage of tornadoes that actually fall into those categories. So you can see this F3, F4, and F5 only make up about 9% of all the total tornadoes that occur. The majority of them are actually relatively small on the scale end. They do cause damage. They can destroy trailer homes. They can push over trees and do a lot of damage. But you can see that the majority of them are relatively on the lower end of that particular scale. And the last scale that we need to talk about is the Sanford-Simpson scale, which is a hurricane scale. Again, divided into different categories, this particular case 1 through 5, based on wind speed, and they also describe the damage that's going to occur. Now, with that being said, the Weather Channel has been asking for the National Oceanographic Atmospheric Administration to reconsider the scale, because even though Hurricane Sandy was relatively low on the hurricane scale, it caused devastating damage or catastrophic damage in some areas. So the winds were not as high, but the flooding potential. So they want to have a scale that might take into consideration the flood impact that's going on in a particular area to be considered as part of that. So as you can see, there's a lot of different scales that you need to be aware of what their names are and how to be able to go back and read a particular chart.
Don't forget to listen to the